হবে রেকর্ড করো, রেকর্ড করে কি হলো, কোনটা দিয়ে নামবো আবার? And you know what is meant by course outcomes? I guess you know.
Yes,
So
sir.
course outcomes are also given in this page. COPO mapping are also given. So please go through this. So today we'll start discussing the first chapter, and the first chapter is on the concept of stability. বানান ভুল আছে, আমি correct করে দেবো. Concept of stability, algebraic criterion, and then we'll discuss one stability criterion, which is Routh-Hurwitz criterion in this particular chapter. Further, we'll discuss other stability criteria like Nyquist criteria, etc. But in this particular chapter, to start with, we'll discuss a very simple and straightforward stability criterion, which is known as Routh stability criterion. আচ্ছা, তোমাদের যদি কোনো কিছু নোট নিতে হয়, সবকিছু আমি যেহেতু চক এন্ড বোর্ডে পড়াই আমি, তো সবকিছু হয়তো যেভাবে আমি প্রেজেন্ট করছি মানে এক্স্যাক্টলি ওটা দেখে আমি রিড আউট করছি না। নোট নিতে হয় তাহলে আনমিউট করে अगेन বলো, তাহলে আমি স্টপ করব, মিনওয়াইল তোমরা লিখে নিতে পারবে।
Okay, ma'am.
Okay. Now, the concept of stability, to discuss the concept of stability, you see, the name of this course is linear control system. A very important term is system. So the prerequisite for this particular course is system theory, which you have already studied in second year, isn't it? System theory. So let's start with the definition of a system. What is the definition of a system? A system can be defined in very many ways, and there could be very many formal definitions for a system. So let's take a simple definition in which a system is basically defined to connect the input to the output. That means if we give a reasonable input to the system, what is meant by reasonable? We'll find that in due course. So a reasonable input to the system, then the system will be able to generate a suitable output. So reasonable input and suitable output. Reasonable means the input should not be unbounded in nature, right? If the system is unbounded, then we cannot predict the behavior of the system in any way, because this itself, the input is unbounded. Try to understand um, this concept intuitively. Since the input itself is unbounded, then it's not possible for us to judge the output, the quality of the system or the performance of the system so far as generation of output is concerned, right? But if the input is bounded and if the input is reasonable, then the output of the system should be a suitable one, which means the output of the system should be in accordance with the input, in accordance with the input. So it can be explained in a different way. That means in accordance with the input means the output should be able to follow the input in a proper manner. That is basically the definition of the system. The output generated from the system, if an input is given to the system, the output should be an acceptable one. The output should be in accordance with the input or should be able to follow the input, right? So if that is not the case, then we find difficulty in working with that particular system. So from there, the concept of stability, the notion of stability was evolved. And in earlier days, আমি ঠিক জানি না কোথায় কি লেখা আছে, anyway, in earlier days it was assumed that if a system exhibited a undamped sustained oscillation at the output, undamped sustained oscillation at the output, then the system will be called or will be termed or will be considered to be an unstable system. That means a system which is not stable, enough. In this particular case, we should keep in mind that the input to the system should not be a sinusoidal one, because in this particular class, in this particular course, we'll be discussing on linear. Our concern is linear system, or to be more precise, linear time invariant system, or LTI systems, right? So in case of a linear system, if I give a sinusoidal input to the system, then the output of the system will be another sinusoid. That means undamped oscillation having a different amplitude and different phase. The frequency will remain same. So if the input is not sinusoid, in that particular case, in earlier days, it was conceived that, bolo kichu bolbe? কিছু জিজ্ঞেস করবে? কোথাও কিছু অসুবিধা হলে জিজ্ঞেস করো।
ম্যাম ওটা মনে হয় ম্যাম ওর ভুল করে আনমিউট হয়ে গেছে তাই ওটা হচ্ছে।
আচ্ছা, না ঠিক আছে, if you find any difficulty in understanding or if you have any query, feel free to ask questions. So where were we? If the input to the system is not sinusoidal, and in that case, if the system shows undamped oscillation at the output, then in earlier days it was considered that the system is unstable. But the notion of stability is not that simple. So the basic line, the basic statement is that a stable system should always be able to follow the input to the system. Okay. So to define stability or to discuss the notion of stability, we can say that it might so happen that an input was given to the system. The system was exhibiting its dynamic behavior. Moreover, in this particular class, we'll discuss dynamic system. We are not bothered about the static system. And I guess you know the definition of the dynamic system, right? Please go through the definition of the dynamic system. So a dynamic system exhibits its dynamic behavior under the influence of integral differential equations, right? So it might so happen that a dynamic system was exhibiting its dynamic behavior. That means it was generating an output which was in accordance with the input. Now, it might so happen that the input is changed due to some reason or other, or the initial condition is changed, or subtle variation is there, subtle changes are there in the system parameter. That particular situation, what will happen to the output of the system? So there is a slight variation in the input, and or slight variation in the initial conditions, and or slight variations in the system parameters, right? So which one is the desert situation? The desert situation, desirable case is that under the slight changes, the output of the system should not deviate much from the actual output exhibited by the system, the earlier output, which was an acceptable one. And the second case could be that due to the slight changes, the output may deviate farther and farther from the previous output, which was an acceptable one, right? So which one is a desirable situation? Obviously the first one, right?
Yes, ma'am. Yes, ma'am.
So
Yes.
we can say that
Ma'am, your
if
screen is not showing.
which one is not showing?
Ma'am,
This one.
screen is showing. The problem must be with your internet connection. Ma'am, screen is visible.
Ma'am, you can continue. No problem.
Okay.
Yes, ma'am, showing. Sir.
Is it okay?
Ma'am, yes, ma'am.
In that case, just leave the session and again rejoin.
Ma'am, it's okay. It's okay. Now it is clear.
So the first case where because of the slight changes, the output of the system doesn't deviate much, right? So we can say that that particular situation is acceptable to us, number one. And under that particular condition, we'll say that the system is a stable one. And the second case, if the output deviates farther and farther and doesn't converge to the earlier output, then we can say that this particular situation is not an acceptable one, and under that particular situation, the system will be said to be an unstable one, right? So in unstable system, we cannot allow the slight perturbations, which we must be able to accommodate. So let's see what's written over here. Moreover, stability is a notion that describes whether the output can follow the input command, and the input command, as I said, should always be bounded, or whether the output gradually deviates farther and farther from the input. So in this regard, we can generally classify the control problems into two groups, right? One type of control problems are known as regulatory kind of problem, and the second type of control problem are grouped as, or are called as, tracking kind of a problem, right? Now let's directly go to this diagram. You can see the diagram, right? So regulatory kind of problem and tracking kind of a problem. Rohit, তুমি record করছো তো?
হ্যাঁ, ma'am.
Okay. So in case of a regulatory kind of a problem, the input is generally said to be a set point. Suppose temperature control of a room. Now the temperature of this particular room has been set to 23 degrees centigrade. Okay. So it's desired that the temperature of this room will be maintained at this particular temperature. So the input command is 23 degrees centigrade or corresponding voltage. If we use one transducer, then we can convert the temperature into a voltage. Okay. So this is the input. This is the input, which is say equal to 23 degree, and the regulatory kind of control problem will maintain the temperature of the system by some means with the help of some controller or whatever. And the output, this is the output of the system after a certain time will be same as the input to the system. That means, you see, the output can follow the input command. And the what is the nature of the input? The nature of the input is constant. Basically, you see, it's constant, right? And the output, it could be like this. It could be, can you follow the cursor? It could be like this as well.
Yes, ma'am. You can follow the course.
So already you have studied in system theory, you have studied different types of responses: under damped, critically damped, over damped, etc. In contrast, in tracking kind of a problem, there is a predefined trajectory embedded into the system. Suppose the flight path of a missile or an aircraft, etc. So this is, suppose the trajectory of the missile, which has been already embedded into the system, into the missile system. And it's required that initially the output may deviate a little bit from the input, but after a certain time, again, it will be able to follow the input. If that be the case, then again, the tracking kind of a system will be called to be, or will said to be a stable one. In this kind of a system, regulatory kind of the system, if the output temperature of the room goes on increasing like this, obviously, we cannot work with that particular system, isn't it? The system is not useful to us, right? That's why the system will be said to be unstable, or if the output is like this, then again, there is a complete disparity between the input and the output cannot follow the input, or the output is not in accordance with the input, and hence the system will be termed as an unstable one. Okay. In this case, if the output trajectory deviates farther and farther like this, just follow the cursor, farther and farther like this, obviously the situation will lead to a catastrophic situation, particularly for a missile or aircraft, etc. So under that particular situation, obviously we cannot work with that particular system. So that's why the system is said to be an unstable one. Okay. Now the thing is, why we are basically bothered about the stability of the system.
Excuse me, ma'am.
Yes. Yes.
Ma'am, that graph is mentioned as output characteristics, but it's the
Which one?
input output value
Which one?
and the
No, no.
early, yeah, this one.
The input and output. This is input, this is output. In this axis, I have plotted input and output vis-a-vis time. In this case also, this is input. IP, this is I, not O.
Okay, okay.
Is my handwriting legible enough?
Yes, ma'am.
Have you gone through the material?
Yes, ma'am. Handwriting is okay. Actually, my handwriting is bad. That's why. আমার ঠিক লেগেছে কারণ আমার হ্যান্ডরাইটিং নিজেই বাজে তাই জন্য
না আমারটা কোটা বাজে ছিল না তোমাদের এতটা
না
লিখতে হয়েছে না
না এটা
না, ঠিক
যথেষ্ট
আছে।
ভালো
ভীষণটা
হ্যাঁ বোঝা যাচ্ছে সবাই বুঝতে
whatever
পারবে
input আর এটা হচ্ছে output, this one is input, this one is output. Clear? Is there any doubt?
নো ম্যাম
No, ma'am.
So why we are so bothered about the stability of the system? As I said, if a system is not a stable one, the system is not, we cannot work with that particular system, we cannot use that particular system, we cannot control that particular system. So to a control engineer or to a system engineer, the first and foremost task is to ascertain the stability of the systems, to find out whether the system is stable or not, right? So let's generally I give one example. Suppose in this particular class, suppose this is not a virtual class, this is a real class. So if I ask one student to lift a heavy load, suppose, okay, so that is in that particular case, the student is basically the system, and the input command to the system is to lift a heavy load. Now, God forbid, if the student is not doing well, and suppose the student is highly feverish, then what will happen? He will not be able to lift the load. He will not be able to follow the input command, right? That is the problem. And if he wants to do that, what will happen? He may start trembling. He may start trembling. That means a sort of sustained oscillation, which is not measured at all. And in the process, he may get collapsed, and the task will not be executed by the system. Task will not be carried out by the system, right? So that means since the task is not being executed, so the purpose will be completely defeated, and hence, if the system in this particular situation, in regular life also, in common life also, commonly we use that the student is not stable, isn't it? He is not stable. He is not doing well and he is not stable. So that is also applicable for any system. That means if the, as I said, if the system is not a stable one, we won't be able to work with that particular system. So that means the system is absolutely meaningless, useless to us. So the first task is to find out whether the system is stable or not. If the system is not stable, then the task of the system engineer or control system engineer is to make the system stable by some means. Okay, and after the system is stable, then we can go for the performance analysis of the system, whether the system is performing in an acceptable form or not. And if the performance of the system is not acceptable, then we can go for, only after making the system stable, if we find that the performance is not acceptable, then we can take some measures for enhancing the performance of the system. Now, there is another very interesting example with the help of which we can let's discuss another example to understand the notion of stability. In this case, we'll consider a system which consists of different types of surfaces on which a ball will be resting. So this is one surface, this is one surface, and a ball is resting at this particular point. Okay, so if the ball is placed at this particular point, and if there is no other input to this particular to this ball, if you don't disturb this ball from this position, then you see at this point the velocity of the ball, it will be a second order system, and we can define two physical quantities to describe the system. One is the velocity, so the velocity of the ball will be 0, and the displacement, if we take this position to be the reference position, this position to be the reference position, then the displacement of the ball is again 0. Velocity is 0, displacement or distance, whatever, that is 0, right? So that was the initial condition of the system. Now suppose we just give an impulsive force on this ball. Just we push the ball either in this direction or in this direction. So what will happen? The ball will start oscillating. One thing I forgot to mention, that the ball is resting on the surface under the action of the friction forces, which is shown with these lines. So because of the presence of the friction forces, what will happen? The ball will start oscillating about this particular position, where velocity and displacement was were 0, and it will start executing a motion, and the motion will be a damped one because of the presence of the friction. And finally, just we have given a push to the ball, and after that we have removed that disturbing force, right? It's not the case that we are constantly pushing the ball. We have pushed the ball and then we have removed that push or removed the disturbing force. Basically, we are applying some disturbance into that particular system. So it will start oscillating, and the oscillation will be a damped oscillation, and finally finally what will happen? The ball will regain